Hi everyone, Assalamualaikum. In this video, we will discuss example 4 under integration by parts using formula integration of u dv equals to uv minus integration of v du. Use integration by parts to solve integration of inverse sine 3x dx, right? Alright, now let we look at the complete solution. From the given question, integration of inverse sine 3x dx, we are given a single function, inverse sine 3x, to integrate. Okay? To integrate a single function, the single function is confirmed to be u, and dx will become dv. Okay? Note that dx always included in dv, right? So we can write equals to integration of u dv. Okay? And then our u equals to inverse sine 3x. And dv equals to dx. Okay? So our u equals to inverse sine 3x and dv equals to dx. Alright? And then from u, we need to differentiate to find du, to substitute into this formula. Okay? And from dv, we need to find v. Okay? And to find v, from dv, we need to integrate. Right? So when we differentiate u equals to inverse sine 3x, we can refer from this formula. Derivative of inverse sine single x equals to 1 over square root of 1 minus x squared. So therefore, derivative of inverse sine 3x equals to 1 over square root of 1 minus 3x bracket squared times 3. Okay. First, we refer from this formula, but we replace x by 3x. Right? And after that, we need to differentiate 3x. Okay, and the answer equals to 3. And the operation sign here must multiplication. Alright? If we have derivative of inverse sine single x, we need to multiply by 1. Okay? But it doesn't change the original function. So that's why we don't need to write times 1 for derivative of inverse sine single x. Right? Right, so now we have derivative of inverse sine 3x equals to 1 over square root of 1 minus bracket 3x squared times 3. So we can write here, okay? But we need to write du as a subject to substitute into this formula. So we move over dv from left hand side, we move to right hand side, okay? So we get multiply by dx, okay? So we can write du equals to 1 over square root of 1 minus bracket 3x squared times 3 times dx. Right? And after that, we simplify. So we get du equals to 3 over square root of 1 minus 3x bracket squared equals to 9x squared dx. Alright? And then from dv, we need to find v. So we need to integrate. Okay, so we integrate both sides from here. Integration of dv equals to integration of dx. Okay, integration of dv means integration of 1 dv. And integration of dx means integration of 1 dx. When we integrate 1 dv, the answer equals to v. And when we integrate 1 dx, the answer equals to x. Okay, no need to write plus c. Okay, because we still not finish our solution. Alright? So we can write v equals to x. Or for quick method, we can just close d for both sides. And when we close d for both sides, we can see v equals to x. Alright? And after that, we need to multiply u times v from this formula. And multiply v and du from this formula. Okay? So we can write integration of u dv equals to uv minus integration of v du. Right? Right, so we replace 1 by 1. We replace u equals to inverse sine 3x and we replace v equals to x. Okay? And to avoid error, we can put single x in front here, because if we put single x beside 3x here, some student tends to multiply x and 3x. And actually, we cannot multiply x and 3x because 3x here means for inverse sine function. Alright? So to avoid error, we better put x in front here. Right? And then minus integration of v, we replace by x, du equals to 3 over square root of 1 minus 9x squared dx. Right? And after that, we have x inverse sine 3x minus, we have 3x in numerator here over square root of 1 minus 9x squared dx. Right? And we still have x inverse sine 3x. There is no integration symbol here, so no need to integrate. But we need to integrate this part, okay? Because we have integration symbol here, okay? From integration by part formula, inside integration, we still have another integration symbol. That's why we call as integration by parts, right? Alright, and in this case, to integrate 3x over square root of 1 minus 9x squared dx, we can discuss later. Okay. Alright, so we still have x inverse sine 3x minus, when we integrate this, we get this. We will discuss later. Okay. And after that, integration of inverse sine 3x dx equals to x inverse sine 3x. We multiply negative in bracket here, so we have negative times negative equals to positive 1 over 3 square root of 1 minus 9x squared plus c. Alright, now how we get this? Okay, integration of 3x over square root of 1 minus 9x squared dx equals to negative 1 over 3 square root of 1 minus x squared plus c. Okay, when we integrate, no more integration sign. Okay, so how to integrate this function? Okay, we can integrate 3x over square root of 1 minus 9x squared dx using integration by u substitution, right? And every time when we use integration by u substitution, we need to identify u. Okay, right? So from here, our u equals to 1 minus 9x squared. Okay. And every time when we integrate using u substitution, we need to differentiate. Okay, we differentiate u with respect to x. It is equals to du over dx, and then equals to negative 18x. Then we need to write dx as a subject. So we just cross multiply from here. So we get equals to du over negative 18x. Right? And after that, from integration of 3x over square root of 1 minus 9x squared dx, we can write equals to integration of, we still have numerator 3x over, we replace 1 minus 9x squared equals to u. And then times, we replace dx equals to du over negative 18x. Okay, then we can simplify x and x here, and we can simplify constant 3 and negative 18, and we move out the constant, so we can write negative 1 over 6. Okay, after we simplify, okay, we move out the constant negative 1 over 6, integration of 1 over square root of u du. Okay, now we get all terms in u and du. Okay, so to integrate this part, so we still have negative 1 over 6, the constant. And then integration of, we can write 1 over set u using properties of indices. It is equals to u to the power of negative half du. Okay? And then negative half here means n not equals to negative 1. So we can integrate using power rule. And when we integrate using power rule, we can add 1 from the original power. So we still have negative 1 over 6, and then u, negative half plus 1 equals to positive half. And then over negative half plus 1 equals to positive half here, and then plus c. And after that, we have negative 1 over 6, and then divide by half means multiply by 2 over 1. And then u to the power of half means square root of u plus c. Then we simplify this, so we get integration of 3x over square root of 1 minus 9x squared dx equals to negative 1 over 3 square root of, we replace u equals to 1 minus 9x squared plus c. Okay, so that's why when we integrate 3x over square root of 1 minus 9x squared dx, the answer equals to negative 1 over 3 square root of 1 minus 9x squared plus c. Okay, you need to show the calculation, okay, to get this answer, right? Alright, from here, okay, we also have term containing radical square root of a squared minus x squared. Okay, a means constant. Okay, so we also can use integration by trigonometric substitution. We can take x equals to a sine theta. In this case, to find a, since the coefficient of x squared is not equals to 1, so you can factorize 9. Okay, so after you factorize, you can get a equals to 1 over 3 sine theta. Okay, so you can try it by yourself, right? So to integrate 3x over square root of 1 minus 9x squared dx, you can choose either integrate using u sub or using trigonometric sub, right? And this is the final answer after we substitute the answer when we integrate this function, right? Coming up next, tabular integrals for repeated function. We will discuss example 5, which is integration of e to x times x squared plus 3 dx. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.